Hello, my name is Stephan Breckle from Indu-Sol, and I'm being asked more and more about asset management by my customers. As a result, I've picked out a very special asset for you today, and that is the switch. Whether from a maintenance, planning, or service perspective, this component is becoming increasingly important. Yet many still see it as just a normal switch. But our switch in particular can do much, much more. That's why I've decided to take out the P24 Plus today, the flagship of our PROmesh family. Because this switch doesn't just switch, it also has various smart sensor functionalities. Today I'm looking at the functions of our P24 Plus together with my friend and colleague Lucas. Together we want to talk about line diagnostics, be it a sporadic cable break, EMC monitoring, for example external coupling, or environmental analyses such as vibrations or temperature rise. Shall we take a look at it now?
Well, let's go. I was really surprised how quickly you installed the device.
Yes, I was surprised myself. But let's see if the hardware configuration works just as quickly. We'll select our P24 now, drag it in here and connect it to our network right away. And of course, now we should take a look at the addressing. As usual, this should first be assigned automatically by the controller, then I can adjust it individually. This would fit so far. And the important thing now is actually the diagnostics. I now directly get the diagnostics for the individual sensors that we mentioned earlier. In this example, I'll just set the 24 volts and also the temperature. And now I also want to have these as cyclic variables.
I can already see leakage current here.
Yes, exactly. And the quality values are also already stored here.
Can we take a look at the device's web interface?
Let's check the web interface right now. Maybe you can say a few words about it?
Yes. Here you can see the homepage of our web interface. Quite simple. You can see which ports are connected and at what speeds. Let's take a look at the details here. There you can also see the line quality value, network load, discards, and errors. I noticed that port 13 is at 20%, so let's take a look at that in the detailed analysis.
Yes, I have actually come up with something. I recently measured a defective line at a customer's site, and I thought I would just go ahead and install it, mainly because it was actually quite amazing. As long as the line is properly installed, the system runs completely without any problems at all. But sporadic issues do occur when vibrations are added.
You wanted to test me, right?
Yep.
But no problem. Relatively clear and easily recognizable on our homepage, the low quality value. Of the line.
It was actually easier for you than I thought, I have to say honestly.
Right?
Yes, because when I was at the customers, it was much harder to find out. Of course, we didn't have any PROmesh series switches integrated. And what I also wanted to say, just so we know, the vibrations, or ultimately the play between port and plug, the manufacturing tolerances ultimately cause the line to fail only occasionally. But what I clearly see here now is that it's not just the play between the tolerances. You can also clearly see here that the line itself already has some abnormalities. That is ultimately exactly what our vortex also reflects. Yes, perhaps for our audience, the vortex is essentially all the information that our service technicians have brought back from the field. So what are the causes of errors? Which field buses and networks are involved? And we've simply prepared that graphically. And you can clearly see there, it's really not just the devices, or often not the devices, it's also cables, connectors, and EMC. Perhaps here again, EMC doesn't mean device EMC, but rather environmental EMC, so what kind of coupling I have on my shield.
And that's exactly where we've come up with something. You can find the leakage current on our web interface, and there you see an FFT over the frequency. How does that help you now? Perhaps based on the frequency that couples onto the shield there, you can determine the source of interference. Yes, if they are higher frequency kilohertz currents, then perhaps frequency converters or similar things create this image. Or do you have your peak in this image more in the 50-60 hertz range? Then it's perhaps more like
power supply or grounding.
Right, the power supply. And additionally, you have a small bar chart down here, so you can see which values were also recorded historically, yes, up to your maximum peak, or also the RMS value, the average.
Yes, you can also clearly see the problem area that I've built in here. Here too, I've come up with something again and made a kind of coupling via a clock generator. And you can clearly see here, as I already imagined, you can now see the frequency components nicely. And of course, also the current that is coupled in.
I was already wondering.
Those are already amazing sensor values, but it's not called a smart sensor with switch functionality by us for nothing.
There's more?
Yes, if you can't show me.
I'll show you. First of all, I have the temperature here.
I think that's damn important. We have some customers, or I personally have some customers, who often say we only have the problem sporadically in the summer. And then, of course, the question is, how high is the ambient temperature in connection with the sporadic problem that then appears?
Definitely. We've already talked about leakage currents. Then we also have humidity, light, in case you open and close the control cabinet.
It could also be very interesting from a security perspective in the future.
Definitely. And acceleration.
Well, I find acceleration very interesting too, because I've had cases where high-performance contactors switch, and I want to know if the coupling or issues I'm getting are related to that contactor switching.
In product management, we test that differently.
Okay, and what do you do?
Exactly this. Let me show you here on the web interface. For the acceleration sensors, you have the X, Y, and Z axes here. There you can see exactly how the device has moved.
And are these values only available on the device?
No, of course not. For higher level networks, they're all available via PLC variables, OPC UA, or REST API.
Okay, can we show that?
Sure. Then let's take a look at it here on the visualization. I have a simple SCADA system from our Indu-Sol factory here, and we can take a look at it. And here we see exactly the values we discussed earlier at our port: line quality, network load, discards, and errors. Or for our environmental monitoring, the leakage currents, voltage, and temperature.
And that's exactly how you can easily see our asset information visualized here. And I must say, from a cable perspective, it's all just low-cost items. But if a failure occurs, it can quickly become a major cost multiplier. So you see, I can get environmental information determined here quite easily.
And that's the point, a smart sensor with switch functionality without needing extra hardware.
And if you have the same expectations for such a product or have had similar experiences, just let us know in the comments.
And if you'd like to test the P24, please let us know. And with that, we'll say goodbye.
So, Lucas, thanks for your time.
Thank you, Stephan.
And thank you for watching.